Buenos dias, good morning, hello everyone. Welcome to my talk. I think people are still coming in, but we're going to try and get started. This is my first conference presentation since before the pandemic, so congratulations on being my first audience. I can't remember how to conference, so if it all goes wrong, then just blame the pandemic. The other thing is I did have a tiny live demo ready for this. I say ready, and when I tried to run it this morning, it didn't work. So everything's going fine so far. It's going to be absolutely perfect. Hello, I am Trisha G. I am a developer advocate, now working at Gradle, Java champion, worked with Java for like 20 odd years. And last year what I was doing, so I used to work for JetBrains doing IntelliJ IDEA and Java stuff. Last year what I was doing is I was busy writing books, because that's what you do when you want to take a break. Why don't you write a book? That's going to be nice and easy. I do not recommend writing books when you're trying to take a break. It is not a good idea. I do have some copies of these books to give away, e-books, not physical books, which I'm already starting to regret because a physical book is nice to hold on to. I just didn't want to take it through security. If you come to the Gradle booth after this and give me your email address, I'll enter you into a raffle to win some of these books if you're interested. So what do all these topics have in common? Working for JetBrains, doing IntelliJ IDEA in Java, writing about those things, and then coming to Gradle to work for Gradle. And the answer is, it's about developer productivity and developer joy. And one of the things I really love about being a developer advocate is it's all about trying to inspire this feeling of, yes, that's cool, that we used to get when we first started programming, maybe. I don't know. Maybe we just look at the computer and go, no, that's awful. And so the thing that I'm really passionate about is developer productivity, making us effective with our tools, making us have that lovely feeling of, yes, it works, now on to the next thing, let's do something cool. The reality of our lives as developers is not usually this. It's usually, okay, the build took 25 minutes, I have no idea if it worked or not, and then when it did finish, some test broke, and we don't know if it's flaky, and we don't really know if it's going to work in CI, and everything's a little tiny bit frustrating. So the reality of working in a sort of day-to-day development jobs is quite often not developer joy, but developer frustration and toil and lots of like stupid little things getting in our way. We actually don't spend a lot of our day writing code. We do spend, if we have a day which isn't full of meetings, this is not my calendar, by the way, obviously. If we don't have meetings and we're actually working on code all day, we're not actually sat down coding a lot of the time. We're quite often doing things like waiting for our local build, debugging build failures, debugging test failures. We put it into CI, and the CI results are different to our local results, and then we spend some time figuring out how all of that works. There was a recent survey which said, that's weird, my screen is not showing the same thing as this screen. There was a recent survey, thank you, which said developers spend approximately 32% of their time actually writing new code or improving existing code. I thought that was quite generous. Who thinks they spend more than 32% of their time writing code? Literally nobody in this room. Who thinks they spend less than 32% of their time writing code? Okay, I'm assuming you're developers, obviously you're developer-centric. Yes, so I think that's probably reasonable that we spend significantly less than half of our day actually writing code. The rest of the time is spent on things like meetings, management. I'm not quite sure what code maintenance means, because maybe that classifies as code, debugging and finding problems and so forth, or maybe deploying or pushing or whatever. I would also probably qualify testing as writing code, but maybe that's a separate thing. The point is, we don't spend as much time actually doing the coding stuff as perhaps we might like to do. There's a quote here from Dell, which says, bottlenecks in the toolchain are holding back the rockstar 10x developers. Now, let's take a quick break to talk about 10x developers. I personally am not a big fan of the term a 10x developer. I think a 10x engineer is kind of one of these mythical creatures like unicorns and the chupacabra. 10x engineers, I haven't worked with a lot of 10x engineers, I'll be honest. Maybe I'm just jealous. Maybe it's because I don't think I'm a 10x engineer that I think that these people don't exist. However, I do think that the 10x engineer is potentially a bit of a myth. There was a book people were from 1987, I think. This talks about developer productivity and measures developer productivity. It's probably from this book, or certainly from some of the material around about this time, this idea of the 10x engineer came about. They were running experiments, they were running this thing called coding wars, and they were pitting developers against each other to measure how productive they were and what things impacted their productivity. What they found is the best programmers, by some measure of best, the best programmers outperformed the worst by 10-to-1 ratio, which may be where this 10x developer came from. Now, the things which made a difference to this, what were the things that impacted that developer productivity? The way the coding wars worked is that you, as the developer who was taking part in it, you worked from your normal office with your normal equipment, from your normal laptop with all the normal noise going on around you. You were competing against someone else inside your organization. You weren't competing against someone else outside of your organization. And what they found mattered is that paired programmers, it doesn't mean pairing together, it means pairing against each other, performed at roughly the same level, which might be a result of the fact they worked at the same organization. The average difference between the two programmers was only 21%, which is not significantly significant. They came from the same organization. But it was the best organizations outperformed the other organizations by 11.1x. So it wasn't a 10x developer necessarily, it was a 10x organization. So while there's a differential in productivity between programmers, there's also a 10-to-1 difference in productivity among software organizations. This is from a different paper around about the same sort of time. They also found that productivity varied from organization to organization, not necessarily developer to developer. The bold fact is that many companies provide developers with a workplace that is so crowded, noisy, and interruptive as to fill their days with frustration. That alone could explain the reduced efficiency, as well as a tendency for good people to migrate elsewhere. This was the conclusion of Peopleware. The conclusion was, it's not necessarily about individual developers. It might be. Let's assume you have some good developers, and we definitely have terrible working environments. Your good developers don't work in the terrible working environments, and any developer is not going to work effectively in a terrible working environment. You need to provide your developers with an effective working environment in order for them to be productive, useful, and hopefully happy. Again, this is from Peopleware. They were looking at things like how much space individual developers had and how noisy it was and how interrupted they were. And so they found that those who performed best had better working environment than those who performed worse. And again, this is from the 80s, and the phrase had not been coined yet, but we're talking about the developer experience here. The things that actually impact your ability as a developer are not necessarily things like which school you went to. They're things like the environment that you're working in. So DPE, Developer Productivity Engineering, is a new practice that at Gradle we're going out and talking to people about. It's not just Gradle, it's people like Netflix and DoorDash and LinkedIn and a bunch of other organizations are looking at how to make developers more effective. And it's not just about more agile processes or more focus on what people are doing, but it's about engineering processes to improve the developer working environment. The sorts of problems it solves are things like long build times, long test cycles, things which get in the way, things that waste your time as a developer and get in the way that we're not necessarily looking at. Things like your local build times, how long it takes to run tests, how long it takes for you to get feedback from the changes that you made. These are all things that could be automated away. And by automating away those things, or at least reducing the amount of time these things take, we are going to do the opposite of what this says. We will improve productivity and decrease cost. So it's these small little things which get in our way of being productive. The premise is that DPE is the next thing to try and help improve our journey as developers. We've had like Lean and Agile and DevOps, and DPE is now an engineering practice to look at in order to improve the process of actually producing good quality software. So all of the things we've done so far in terms of Agile and Lean, they're not finding all the bottlenecks, all the toil, all the things which are frustrating to us. Some of these things are things that developers have complained about. Some of these things are things that developers know are terrible and yet have run out of energy or effort to actually complain about, like long build times, flaky tests. I'll get onto flaky tests in a minute. So a 10x organization should be reducing build and test feedback times, improving the consistency and reliability of builds. these are some of these things. It's not just about office floor space and how few meetings you have. It's what can be done to reduce the feedback cycle with tooling, with automation, in order to improve your experience as a developer. Let's look at some of the pain points that we see as developers, some of the things that get in the way of actually getting the job done. The first pain point is waiting for builds and tests to complete. Is anyone here tracking local build and test times? Some of you are, that's quite good. It's not surprising that the majority of the people in this room are not tracking local build and test times. We probably have a fair idea. Like, let's see, whose build and test cycle takes longer than 20 minutes? Okay, don't be afraid, it's fine. Longer than half an hour? Okay. Fine. Longer than 10 minutes. Okay, longer than 5 minutes. Okay, who has a build and test cycle less than 5 minutes? That's good. Less than 2 minutes. 2 people, okay. That's interesting, and I think that's probably that's fairly indicative. Obviously, your local build and test times depend on things like, do you have tests? Because some people don't. Are you building a monorepo? Are you doing microservices? Which technologies are you using? Those kinds of things. So there's going to be quite a lot of variation. That doesn't necessarily mean you have to accept local build times of over half an hour. Because what are you doing while you're waiting for that thing to finish? I mean, you might be multitasking, but we all know how great humans are at multitasking, right? Do we? Okay, so here's another book. My boss likes to call it, the stuff that we're talking about here, the ancient wisdom of the 70s and 80s. And I do not like him calling it that because it makes me feel old. But here's another book from the 70s or 80s called The Goal. This is where they first talked about the theory of constraints. And again, this is about being more effective in business. The goal and the theory of constraints talks about the only initiatives which will positively impact performance of your organization, for example, are ones which will increase throughput while simultaneously decreasing cost. Now, I want to stop and think about this for a little bit, because do you think that decreasing the number of developers in your organization is going to increase throughput? People who are laying off developers are not doing the right thing. So, in order to increase the productivity of your organization, we need to be looking at things which are going to increase the throughput of the organization, and ideally, this should decrease the cost too. If you've got faster build times, this will improve the creative flow of the developers. If you have faster build times and faster feedback, you can do more local builds. This is an example of a couple of teams. We have a team of 11 developers with a build time of 4 minutes, which is nice in my world. A 4-minute build time is nice. And you get the number of local builds you get in a week, I think it was 850. Now, if you have 6 developers, so nearly half the number of developers, but your build time is 1 minute, you're going to do 1,000 builds a week, even though you have fewer developers. Number of builds is not necessarily an indication of how productive you are as a team, but if you have a 1-minute build time, you haven't disappeared off to work on something else. Within 1 minute, you get the feedback. You understand whether your code works. Everything is still sort of local in your memory for if something fails, and you can fix it much faster. So you can be much more productive. It's not just about reducing the time for the build, it's about reducing this context switching and this mental load of trying to juggle 15 things at once. And that's why very fast feedback is important. I'm not a big fan of this slide because there's a lot of things on here, but it is a good slide because the point is that if you've got faster feedback cycles, this leads to a whole bunch of great outcomes. For example, faster feedback, you build more often, so you can have smaller change sets, fewer merge conflicts, faster faster to market. If you build more often, you get earlier quality checks, fewer downstream incidents. So all of this can lead to better quality. And then if you have faster feedback cycles, you have less idle time, less context switching, less waiting, more focused developers, which improves quality and improves productivity. And if you are faster at building stuff, you improve productivity. Overall, if you have faster feedback cycles, which is changing one thing, you get all of this great downstream effects, which leads to higher quality code and higher productivity teams, just by changing one thing. So, how do you get faster feedback cycles? the way that we're talking about it from the Gradle point of view, is acceleration technologies, obviously to accelerate the feedback, accelerate your builds and your test cycles. We're going to cover briefly all of these things, including build cache, predictive test selection, test distribution, and performance continuity, and I'll talk about what all of that means. Build caching speeds up your builds and your tests. If you're using Gradle, you may already be familiar with build caching. Who's using Gradle, by the way? Yay. Who's using Maven? Slightly more of you, okay. That's fine too. Maven is fine too. Look, Maven loves Gradle. Gradle loves Maven. It's all good. So build caching speeds up your builds and tests. The way build caching works, right, so build caching is introduced by Gradle, blah, blah, blah. Build caching works at a local level and on a remote level. So you can cache your build locally on your laptop or remotely, so you can share the build cache between multiple people in your team. What we're talking about in terms of build caching is for each of your Gradle tasks or for each of your Maven goal executions, if the inputs are the same, the outputs should be the same. So if your source code is the same, if your resources, your input files, and your archives, etc., if they're all the same, the output should be the same. So the output can be cacheable. So if you're in a multi-module project or multi-project application, then you don't have to rebuild every single one of your modules or every single part of your application if only a small amount of your application changed. You can cache the results of that. I really want to do a demo for this, and I'm not sure it's going to work. Let's have a look. Let's see. Yeah, that worked. So let's try that again. So I have a project here. Let me show it to you. This is a Maven project. This is a project I used to work on in the olden days when I worked for MongoDB. So it's a multi-module Maven project. It's not super complicated, but it's not trivial either. And it usually takes, that took 3 minutes. It usually takes about a minute and a half. I just updated this project, by the way, so obviously everything's going to go wrong because I haven't done it lately. It usually takes about a minute and a half to run a full clean build. It does integration tests against MongoDB in Docker, so we're not talking about just unit tests. We are talking some end-to-end tests as well. But still, like a minute and a half is not bad for a project like this. It's pretty fast, actually. I tell you what, though, it is quite a long time to wait for a build when you're standing up and talking to a room full of people, because a minute and a half feels like eternity when you lot are looking at me, waiting for this to fail so that you can laugh at me. Thanks, guys. That's great. Sorry, I shouldn't use the word guys. Thank you, everybody. That's great. And I also love the fact that the output of this is not showing me anything, so it just likes to give me a heart attack and sit there for 90 minutes until it eventually does actually pass. Talk amongst yourselves. Have I got any other questions to ask you? Are we Java developers here? Java? Okay, lots of you. Web front-end people? Mobile? I don't know, a bit mobile, a bit not. What else? Non-developers who are interested in developer topics. Great, that's good too, that's fine. It's still building. Let's pretend this takes a minute and a half. Okay, so now you're getting the idea, and this is why fast feedback loops are important, because I've already forgotten what I was doing, and if it fails, I won't remember what happened. And while that's doing its thing, I'll move on to the next part of the demo. So I am going to use Gradle Enterprise, which is not the same as Gradle. I'm going to use Gradle Enterprise to apply a build cache to this Maven project. I need to find where it was first. Let's look for... Okay, so with just a few small lines of XML, because we're talking Maven, I can... Where am I looking at this? .maven. Nope, that's not what I wanted. Okay, so what I'm doing is just adding a bit of configuration to enable Gradle Enterprise from Maven and point it to a server to report all the build information to, and also to potentially act as a remote build cache as well. What do you mean reinstalling sample data? This whole process is completely different to how it was before. I'm going to have to find a new project. I wonder if there we go. If I start another build, will it break everything? I hate live demos. I don't know why I'm doing live demos. Talk amongst yourselves. Yeah, okay. That took 3 minutes and 40 minutes, 3 minutes and 40 seconds, which I know it said that's what it took before, but before it was downloading the whole internet, so I just thought it was because it was downloading the whole internet. Let's go out on a limb. I don't know if this is going to work. I'm going to try and do cleaning and... I'm going to try and do that, but in the background, I'll carry on doing the rest of the presentation and come back and find out if it worked or not. It should be using the build cache. It should take less time. It might even be saying, I might have to do it another time to make sure that it's put everything in the cache. But we should see a good result, in theory. So a local build cache will give you great performance improvements over your local build, obviously, because if you just recently built it and then you change one line of code, your build shouldn't take as long because it'll only rebuild the bits that are important to you. What's really interesting is when you get to a remote build cache. So let's say you come to work in the first thing in the morning and people have been committing to the project overnight or whatever, or you haven't been working on the project for a little while. Normally, when you do a fetch of all of the updated code and do a rebuild to make sure everything's working, first thing in the morning, for example, that's like go off, have a coffee, have breakfast, come back, and it might have finished. With the remote build cache, if CI has already built that commit, CI already has the results of doing that build. So you can just download those results and run it from the remote build cache, and it should take significantly less time. So if anyone has built that before, you get the benefits of that build. So you don't have to keep rebuilding everywhere and using all these resources on everyone's machines to try and just keep rebuilding the same thing. Let's have a quick peek, see if the build cache worked. That's the error I was getting before. Let's pretend it worked and everything is fine. Oh, I can show you something though. I was working on Apache Camel. There's a couple of people here who have been working on Apache Camel. Anyone working on Apache Camel? Okay. So I was looking at Apache Camel because it's a lovely, complicated project with a huge build time of like 20 minutes without running all the tests. And so here we go. We've got builds of 23 minutes, builds of 18 minutes when you run the full build. And then when I applied build caching to that and also tweaked it so that the build cache is a bit more effective, the build time comes down to 3 minutes. So it went from a 20-minute build to a 3-minute build. Now imagine how much more helpful that is when you don't have to go off and do something else for 20 minutes only to find that your build failed. This is like super useful. Okay, so that's build caching. Test distribution is about parallelizing the test execution. So this is about running your tests in parallel, be they unit tests, integration tests, or acceptance tests, whatever you've got. So you can run stuff in parallel on your machine. Obviously, you can run them in parallel, and you can have, it's limited to the number of CPUs you have and the amount of resources you have on your local machine. But there are ways to run some stuff in parallel on your local machine. There are ways to get your CI environment to do fan-out. Often involves, almost physically partitioning up your different test files and allocating them to individual agents, but you can run them in parallel that way. Some of these things don't necessarily help us as much as we want them to. So, like I said, when you're running stuff in parallel on your local machine, that's dependent upon the number of cores you have, for example. The CI fan-out is fine, but that doesn't work when you're running your local build. You're not doing CI fan-out on your local build. Test distribution, for example, with Gradle Enterprise, but it doesn't have to be with Gradle Enterprise. I worked at a place where we built our own test distribution engine. And what it does is it takes the list of tests and just allocates it to agents as and when they become available. It is limited by, for example, the run of your longest test. So if you have one test class which has got millions of tests in and that takes 20 minutes, you'll never have a test time which is less than 20 minutes. You have to partition that up into individual tests. But if you have lots and lots of tests which run in a small amount of time, you can just allocate them to multiple agents. And then the more agents you have, the less time it takes. So roughly, doubling the number of executors cuts the build time in half. And what we found is that when Netflix started using test distribution, they got a 62-minute test cycle time down to 5 minutes, just by running it in parallel on multiple machines. Now that is a huge improvement on productivity. So you are definitely running all of your tests, and you're not having to wait an hour to find out if you broke one test. You can even use machine learning. I know AI is like a big fat deal right now, but you can even use machine learning to make things a little bit easier. So there was a paper which Facebook created, which I am in the middle of reading, but it's quite long and it's quite dry and it's a little bit difficult. But there's a paper that Facebook did around the predictive test selection that they were doing at Facebook. And the idea about predictive test selection is you look at the code changes, and it uses a learning algorithm to figure out which tests are most likely to give you useful feedback on those specific changes. It doesn't look at dependencies because all tests are ultimately dependent on everything everywhere. But it just figures out, I'm going to run this small subset of tests because they are most likely to tell me whether this code works or not. And we've generally found that with predictive test selection, your test cycle time will be about, I think it was about 30% of your normal test cycle time, because you only run 30% of the tests. And it's about 95% effective. You're probably not going to run it on when you're going to run the full build cycle, when you're doing your deployment, you probably want to run everything. You're not going to guess which tests are going to give you the best indication of whether it worked or not. But when you're running local builds or just checking your pull request before you submit it, you want to do a sanity check. And this might be a really good way to do a sanity check to make sure you haven't broken anything critical. When you use all of these things together, the build cache, predictive test selection, test distribution, and performance continuity, which I'll come into in a minute, this is how you can reduce your cycle times right down. Your build cache will reduce the amount of time it takes to do the build. The test acceleration technologies will help reduce the amount of time it takes to run the tests. And your feedback cycle time will be significantly less. And then you're not waiting around, you're not context switching, you're not getting frustrated by the fact that you waited 40 minutes for a build and then one thing broke. So the question we should be asking ourselves going forward is not, is the build and test cycle fast enough? Because most developers will say, yeah, it's kind of fast enough, because I have ways to work around the fact that it's not quite as fast as I would like it to be. We should be asking ourselves, is the build and test cycle as fast as it could possibly be? And for me, this was a real change in mindset, because for me, I was always like, well, it's kind of fine, 6 minutes is all right, but is it as fast as it could possibly be? No, it's definitely not as fast as it could possibly be. Do I not deserve it to be as fast as it could possibly be in order to get the fastest feedback, in order to be effective? Yes, I do. Another pain point I've often found as a developer is that once your build is broken, it's kind of difficult to figure out what's broken with it, particularly on a CI environment, but also on local environments as well. So it actually helps if you can actually have some visibility over your builds or over someone else's builds. And so Gradle has the Gradle build scan. The build scan is free and available to use. The build scan is free and available to use. You might not want to use it in your companies if they're worried about sending your build data out to a server outside of your organization. But you can use it with your own projects, and you can use it to take a look to see how it works. The build scan is quite a useful way of being able to say to a colleague, my build broke and I'm not really sure what happened, and you can send them a link to the build scan and they can have a look at what was the output, what were the dependencies, what was your tool chain, how did it work? Similarly with a CI build, so that you can actually look at the CI build yourself and figure out what was happening here, how do I figure out what went wrong with it? And I saw build scans ages ago, long before I worked for Gradle, and I didn't really understand their significance, because I'm this is the same as the output on my local machine, so how is that helpful? But the fact is that when something fails on my local machine, and I need to talk to someone who's remote, they can't see what failed on my local machine and what it looks like. They can't drill down and have a look at my stack trace and figure out what happened. The build scan allows you to do that. It doesn't have to be a build scan. It could be any technology that you can choose in order to share the output of your build to troubleshoot the problems. If you want to find out more information, this is here. I do have a link right at the end which has got loads of information on all the stuff and the slides and everything. The other thing that's important is to be able to track failure rates, all kinds of failure rates. One of the things that I've found interesting is that you can work in teams like where one developer, for example, consistently has problems with their build, and they just don't even really think about it. They either complain about it or they don't complain about it. They're just like, this is just my life. My build and test cycle just never really works. But if you've got monitoring and if you've got tracking and you can figure out, I don't mean monitoring your productivity. I mean being able to figure out like, oh, your build takes 20 minutes longer than everyone else's build. Maybe we should do something about that. Maybe there's a problem with your environment that we can help you with. I was talking to someone about using these sorts of things to justify getting better hardware for the developers. Because if you're tracking local build times and it takes 20 minutes, and you think about the hourly rate of a developer, you can quickly do the maths to figure out, like, maybe we can afford more laptops if we can save this amount of time by having better hardware. And in terms of the failures as well, if we can see that everyone is being hit by similar types of failures, as even across teams, different teams having the same kinds of failures, and we can see that, then we can do something about that. We can address that problem. Yes, my favorite thing, flaky tests. I absolutely hate flaky tests and flaky builds. I mean, is there anything worse than running a test and it fails? Well, worse, run a test, it goes green, and then you put it into CI and your test fails, and you don't know why, and you can't reproduce that. So what do you do when you've got a test that fails? Well, you try it again, and then you rerun it, and then you rerun it, and then you just say, oh, I don't care, it's probably fine, it's flaky, it's all right, no problem, it can't possibly be wrong. There's a recent survey that I found which said, our analysis revealed that rerunning the failing build and attempting to repair the flaking tests were the most common actions. So the most common thing to do when something fails is rerun it. Yeah, but like, what are you expecting? It either fails again, in which case it's definitely broken, or it doesn't fail, in which case something is definitely broken, because it still failed once, right? And it said, this survey said that developers who experience flaky tests more often are more likely to take no action in response to them. So when you have a flaky test which passes and fails, what do? You learn to ignore it. It's like, oh, that's flaky, that's fine. And in the meantime, your CI environment and your local environment are running and rerunning these tests, using up energy, using up emotional energy, to do what? So that you can just ignore it and pretend everything's fine. So a really useful thing to do is to identify flaky tests. I worked in an organization about 15 years ago, and there was a flaky test detector, and it was called Trisha. And Trisha would come in the mornings and rerun all the tests that failed in CI overnight, and I would send out an email, and I would say, these ones are definitely broken, and these ones are flaky. And people found that so helpful, they automated that process. So they would rerun the tests automatically in CI and create a report which would show a sort of flakiness level, how flaky these tests are. And so that's fine. But you need to identify the flaky tests. But then what I would really like you to do is I'd really like you to fix them. Dave Farley has a really good video on the 5 causes of test intermittency. Fixing flaky tests is difficult. It can be hard. It's usually down to things like timing problems and weights and changing infrastructure underneath you and things like that. Just because it's difficult doesn't mean you shouldn't do it. It can quite often point to problems like race conditions in production code. It can quite often point to problems which are endemic across your whole application. So for example, some sort of problem with the way you do the messaging and handle messages. So fixing flaky tests will be usually the thing which finds that really weird production problem which could actually have a major impact on your customers. Another pain point, no metrics or KPI observability. So all of this is great. You can optimize your build, you can have your build cache, you can use predictive test selection, have your cycle times right back down again. But if you don't have visibility over your build times and over your failure rates and over your flaky tests, problems are going to sneak back in. It doesn't really matter what you improve as long as you're constantly improving something. Because if you're doing nothing, it's getting worse. It's not staying in a steady state. This is just entropy. Things will just get worse if you don't watch stuff, if you don't look at it, and if you don't do something to improve things. I mean, We're developers, we know that. Like, do you know why my demo doesn't work? My demo doesn't work because I didn't do anything to the code for 3 months, and it stopped working, and I don't know why. Oh, speaking of the demo, let's see if it worked. Oh yeah, no, that's right, it didn't work, did it? Oh, rubbish. I'm going to spend all day trying to get that to work again. It's going to drive me crazy. I've just finished reading Mike Nygaard's Release It, the second edition, and there was a really interesting point he said in there, because that book is all about releasing production. How do you release production code that's stable and doesn't fall over and doesn't cause problems for your customers? And he says, the tools, services, and environments that developers need to do their jobs, for example, your IDEs, your QA environments, your build tools, should be treated with production-level SLAs. The development platform is the production environment for the job of creating software. Now, I've worked in a lot of organizations where developers' machines were not great, where the QA machines were just a mess of like redeployed crap, and they're never cleaned up, where your test data is kind of the best that you could do, but you know, it's not really like production data. And it's kind of fine because it's not production. But it is production. It's production for the process of creating production level code. If you have crap between here and production, you don't know that you've got good quality code going into production. We need to be treating the developer toolchain as production level environment, which needs to be looked after properly, which means having metrics and observability and trying to spend time improving it so it is the best it can possibly be. Another pain point is inefficient use of CI resources. Now, theoretically, of course, if you improve the build times and decrease them, there's a couple of things that could happen. One, you could be using fewer resources, you could be spending less money on your cloud bill, or two, you could be doing twice as many builds as you were doing before. Either way, you're using your resources more efficiently. So you're either spending less money or getting more out of the resources that you have. So if you reduce your cycle times, you also you are going to improve the use of CI, for example. In summary, good, got time for questions. 10x developers might be a myth, but a 10x organization is real, and there are things that your organization can do to make you more productive, more effective, and happier as a developer. Developer productivity is deeply linked to the developer experience. And developer experience is not just having better hardware. I did a Google the other day to go, what is developer experience? And the answer was, buy better laptops. It's like, yes, we could buy better laptops. But there's a lot of other things we can be doing to improve the developer experience. If you do nothing about developer productivity, life will get worse. It won't steady state. It won't stay the same. It will get worse. Fast feedback, efficient troubleshooting, and reliable cycles are key to having a better experience for developers. And the first thing to do is to observe. You don't have to buy Gradle Enterprise, but if you do, that would be great. You don't have to buy a new tool to do this sort of thing. You don't have to start implementing like build caching. The first thing to do is observe. What are your local build times? What are your CI build times? What are your tests doing? Are they flaky? So the first thing to do is have a look at your environment, look at your local environment and your CI environments and figure out what's really happening there. Then you can take action as to where the inefficiencies are. And proactively solve problems for the whole team. I think this is the thing that appeals to me most about developer productivity. Yes, it benefits me as an individual, but all of these things that you do, the build caching, observability, flaky tests, all of those things, they improve life for everybody. You make one improvement and everybody benefits from that, not just one developer. And that's a massive multiplier. There's a survey that says, on Tech Validate, it says that DPE, developer productivity engineering, fosters developer joy. 81% of surveyed IT professionals would agree that DPE's impact on their toolchain makes their job more enjoyable. For this is key to me. This is not about squeezing more out of developers. This is about making ourselves more effective, more productive, but happier because we're not hanging around waiting for stupid stuff to happen. We're not being blocked. We're not having to multitask and switch contexts all the time. It just makes our jobs much easier and nicer. The other thing to mention, because, you know, it's nice to have happy developers, but at the end of the day, what does the business care about? The business cares about the bottom line. But if you are improving build times, feedback cycles, and the reliability of your tests, Then, if you improve those things, this is all, in fact, this is all bad. If you've got inefficient troubleshooting, testing, and CI, then you're going to end up with worse quality of service. So if you get rid of these problems, you get better quality of service, better productivity, faster time to delivery, which improves revenue, decreases costs, and improves the reputation of your brand. So improving feedback cycle times, which is great for us, actually impacts the business all the way across all the levels that interest them the most. So, next steps. I've inspired you with my amazing talk. What do you want to do? So I've got a page, it's currently on my blog right now, with the slides to this talk. Hopefully the video will go on here at some point, but also there's another link to a platform called Influitive that we're hosting, which allows you to start your DPE journey, and it gives you a whole bunch of resources to check out to figure out what is developer productivity engineering, how can you go about implementing it in your organization, what sorts of steps can you take, what kinds of things do you care about. So I highly recommend you take a look and check that out. And well, let's leave that up. That's all. Thank you very much. I actually have time for questions, which almost never happens. Yes, there's a mic there.
One of the problems I faced in the past is like when you had this situation when nobody owns, and therefore everybody is paying, is having the pain, but nobody can afford to fix it. So I was in an organization that until a small team, actually another person and I, took ownership of the CI and fixed it, and then everybody loved us. But before that, they were suffering this for a year or so. So how do you manage that in an organization when nobody owns the CI?
Yeah, that's a really good question. So the question is, there are plenty of teams out there where nobody owns this area. Nobody owns CI, nobody owns test feedback cycles, anything like that, particularly in smaller organizations. Larger organizations have things like platform engineering, or maybe DevOps teams might do some of this sort of thing. It is a problem, especially if developers' objectives and goals are around fixing issues, writing lines of code, doing big architecture. There's a couple of ways to go about it, but it depends a lot on your organization. You can always do the beg for forgiveness, not ask for permission, and just go ahead and just do it. If you feel like you can take, I don't know, a couple of cycles, a couple of sprints or something, just to show small improvements. For example, implementing a build cache, if you could do that quickly, and you could say, look what we did for everybody, can I have a little bit more time to do the next step and take the next step? Or do the observability, take a small amount of time. You can actually use Maven Gradle plugins to store the data of local build times, and so you could have a look and say, look, this is how much time we're spending with these sorts of problems. And then you can use that to go back to management, whoever that is, and say, we need some time to invest in that. The other thing is some organizations have 20% time, so you can use your 20% time on that kind of thing, spend like half a day a week on build problems or CI problems. It is a problem. I think the first thing to do is to try and either identify to your management that there is a problem, or take some small steps to show how you have fixed a small problem and how it benefited everybody, and then use that as the platform to say, I would like to spend some time over the next quarter, 2 quarters, being the DPE engineer, helping everybody's productivity. Can I have that folded into my objectives, and then I can actually do something effective going forward? Okay? More questions?
Yeah, thanks for the talk. It was really inspiring. I just have a question. It's been a while since I'm trying to convince my management for Gradle Enterprise. To be honest, since February, I guess. Finally, we are on a track, but what I see that top management, they don't understand the things that we cannot measure. For example, we can set a goal, like our build time should be like 15%, decrease by 15% or like half. But when I'm talking about observability, like flaky tests and test distribution, and the thing that just impact the productivity, but somehow not in a measurable way, it's extremely hard to prove. Maybe you can give some tips how to explain this to managers who don't really take part in real development and don't understand this.
Yeah, so the question is, how can you let top management know why this is important, right? And use maybe metrics or whatever to drive that message home. Again, that is definitely a tricky thing. Some of the DPE organizations that we've seen that are effective are the developers want to do it, top level management wants to do it, so you kind of end up meeting in the middle. That works very well. How do you do it when it's from the bottom up? I think, again, some of the things are around trying to sell it as a kind of cost-saving thing. Like, for example, predictive test selection, test distribution, build cache, all saves time on your build, right? So you can even put a financial amount on that. If your builds are 75% of what they used to be, that 25% costs how much based on your developer salary? You know, you're saving X amount of money. If you use test distribution and you can halve the testing time with just adding one extra agent, that's kind of a significant savings in terms of like money. It's a bit crude because it's not really the same thing, and it's not about money. It is about having headspace and being without context switching and being more effective, but you can sometimes use some of these crude metrics. But then your point was like, what happens if you don't have metrics? Yeah, I mean, flaky tests is an interesting one, for example. You can have metrics on the number of flaky tests you have, and then it's difficult to say, this costs us X amount in terms of opportunity or whatever. Again, a really crude measurement for that is, for every flaky test, it gets rerun once or 5 times in your CI environment. So instead of that test taking, I don't know, 10 milliseconds, it takes 2 seconds. That's not much, but every build, it takes 2 seconds. And so, yes, the answer is to try and find some time or money or metric thing to put some value on this thing. Okay? More questions?
Hi. I would like to ask you about the configuration cache, which I think it's still not final, but would it also improve the execution of tests?
I don't know the answer to that question, but if you come to the booth afterwards, someone else will probably know the answer to that question.
Thank you.
You're welcome.
Hi, quick question. So, and I think it's related also to the question about Gradle. So, how do you fit DORA metrics in here?
Dollar metrics?
DORA metrics.
Oh, DORA metrics.
Yes.
Ah, yes. No, there is we have a blog about that somewhere. I think we have a blog about that. Again, I don't know the direct answer to that, but we have some blogs around how to use other metrics to help push in this direction. For example, there's definitely a blog about space. These are things I don't really know that much about, but like the space framework and a bunch of other stuff. But yes, we do. If you check out the Gradle blog, we do have a whole bunch of stuff, which a lot of that stuff is aimed at management, like how to pitch this so that it fits into management's KPIs or objectives or whatever. Yeah, hopefully be able to find something there. If not, send me an email and I can find someone who can answer that question. Okay? Aki.
Hi, congratulations on your talk.
Thank
I found
you.
it excellent. I'm curious about the build. To cache a build, do I have to create separate packages in order to be efficient?
It's not necessarily about creating separate packages. It is about, there's a number of things you can do to improve the cacheability of your application, obviously. But it works at the task level, so it doesn't necessarily have to be a modular application. If you're running different tasks and different phases, those things can be cached. But obviously, the more modular your application is, the more cacheable it is, because if things are off here, not affected by your changes, then they can be cached. So, I mean, I think the answer is going to be it depends. I think that's it.
It is, yes. Thank you very much.
Thank you very much. Thanks.